Well, good morning, everyone, and thank you so much for joining us today. My name is Heather Galt. I'm the VP of Marketing at PPO, and we're really happy you were able to be with us today. I'm going to get things started, and then I'll very quickly turn it over to our two speakers today and get the exciting part of this all happening. So as you know, our topic for today is preventing contamination and focusing on detection. A couple of little housekeeping items before we get started. So the first thing is you should see on the bottom of your screen a little control bar there. And if you ever have any questions through the course of the presentation, please feel free to click on those little buttons and just ask a question. You can use the Q&A or the chat function. If you use the Q&A function, you'll see down the bottom there, that will come to the speakers. So that question will be asked just to the speakers and not to the others on the call. But if you do use the chat function, just be aware that everyone who's participating in today's call will see the chat. So that's a little bit of a difference and something just to be aware of. We are recording the session today, so it will be available to you through our website probably 24 to 48 hours from now, and you'll be able to find that on ppo.ca/resources. We also have a number of previous webinars that we've run, and you can find all those in the same place. So if you're curious about some of the topics we've covered in the past, they're all available to you on our website. I'm very pleased to introduce our two speakers for today. Olga Pawluczyk, who's the CEO of P&P Optica, is going to speak first today, and I'll talk a little bit in a minute about what she'll cover. And we're so excited to have Casey Gallimore from NAMI with us as well. So Casey is the Director of Regulatory and Scientific Affairs at NAMI. And as many of you will know from seeing Casey at previous industry events, she has a great deal of meat industry experience as well. So we're really pleased that she's going to be here today to talk a little bit about what NAMI is working on related to detection and also about her experience in the meat industry. So welcome to Ola and to Casey. Oh, skimming ahead. So today we're going to start off with a sort of little bit of a science class. Ola's really good at these and making things easy to understand, way better than I would be able to do. So she's going to start by talking about how we understand detection, and not only understanding what a detector does, but how we can actually really clearly understand how detectors are performing as well. Then she's going to look at some of the different approaches we have today to food in food processing for detection, and get into a little more depth on the technology that PPO uses called hyperspectral imaging, which is a relatively new detection technology. She'll wrap up by talking a little bit about how data and insights can be supported with some of the different technologies available today, and then hand it over to Casey, who'll talk a little bit about what the industry is thinking, how the industry is thinking about detection and detection systems, and where she sees things going. So if you have questions at any time, please, as I said before, use the Q&A function or the chat function. I probably won't disrupt the speakers as they're going through, but we'll have an opportunity for Q&A at the end, and all the questions that come up through the session will be brought up to the speakers at the end. And with that, I will turn it over to Olga.
Thank you, Heather. Welcome, everybody. I'm super thrilled to have Casey join us afterwards. So while I probably will bore you a little bit, she'll provide the entertainment at the end of the presentation. So Heather, next slide, please. So what is detection? And detection is not just the act of seeing. Next slide. It actually is act of making a decision about seeing something. So did something occur, or how do I measure something? Next slide. And when you look at what affects detection, there are a whole bunch of technical issues that one should consider. So for example, resolution of a detector, and it doesn't matter whether it's vision or X-ray or any other type of detection, is very important. There is a limit at which point, if you zoom into your information, you will not gain any benefits, like you see on this picture. Resolution limits what you can see, the detail you can see. Next. The other aspect is things like motion. Motion also limits what you can see. So you can see on the right hand side, the leaves were moving. They're much more blurry and much less defined. In detection on processing line, obviously we have a lot of motion. And now as our speeds are increasing on processing lines, this also impacts how detectors can behave. and what they can see. Next. Finally, things like, how much energy, how much information is there really? So lighting conditions for vision systems, or the amount of X-rays, or even the strength of the transducer in ultrasound, all will affect what you can actually see. One that not too many people think about is the complexity of the background. I took these pictures with my iPhone yesterday, and it's so much easier to see things when they're on a uniform background, and then on a carpet, things start getting lost, right? Like, so when you have more complex background, it's that much more difficult to detect the same object in the same identical conditions. Next. And really, to illustrate that, think about hearing a pin drop in a meeting room versus the airport versus a concert. It's important to not just look at how strong a signal is, but also what's the background of that signal. What is the signal to noise ratio of the environment and the detector itself. Next, Heather. So depending on what you have, what your detector behaves like, and what its physical limitations are, and what the noise is, same object will be easier or more difficult to detect. And again, it's completely independent of technology. Next. So kind of stepping back, we talked a little bit about what detectors are and what detection is. But when you think about any event where you have to make a decision, did this event occur or not? So now with COVID, testing is very easy. Do I have COVID or do I not? Is there a foreign contaminant in my production or not? Is my product good quality or not? Next. That's a simple question, but what we're actually measuring does not exactly reflect reality. No measurement is perfect. So things like false positive rates might not be detected. We might not know about whether something is actually, a positive COVID test, or did the test make a mistake? I am diagnosed as COVID, true, but I'm actually not sick. And those are extremely difficult to find, especially if you're running a production line. How do you know that all the things that you rejected for actual presence of foreign objects, or is it a detection mistake? Next, please. So again, what we see when we're detecting things in a plant situation, we see the true positives, or detector said it's a positive, and it is a positive, but we oftentimes will not know if some portion of it is false positive, or the detector sees it, but it actually is a perfectly fine object, or there is no foreign material or sickness. And we also don't know the what is the true negative aspect. Some negatives will be misrepresented by our statistics. Thank you. So you might step back, okay, Olga, well, is there such a thing as a perfect detection system? And this is a kind of a slide that one of my profs used on me a long time ago. There isn't. If you go to next. The only perfect detection system, so if you wanted to find cancer in people, if you told everybody they have cancer, that would be the only perfect method of finding all cancers. But you would also reject every single person who doesn't have cancer would also wrongly think that they have. So go next. So one of the, I always look at other parallel universes. So medical imaging is a really great illustrator for finding and detecting objects online. What does medicine do? So good understanding of the problem is absolutely key for figuring out what detection model to use, picking up the right approach, but also understanding the trade-offs. So when you understand the trade-offs, you can mitigate problems, you can kind of improve your detection systems to make sure that you're going to be providing the highest probability of detection. So for example, presentation of uniform thickness of meat is very important for X-rays, metal detectors, and even vision systems. So you mitigate the problem by understanding what the trade-offs of your detection system are. And medicine also often uses a multi-hurdle approach. So to detect disease, maybe sometimes X-rays will not be great because you only see bones and don't see soft tissue. So how do you see soft tissue? You go to MRIs, or maybe you do some sort of vascular imaging. Thank you. The other aspect of detection is also understanding what are you trying to detect and how likely is it to actually be occurring. So, some objects might appear in your production lines or on your production lines very rarely. So an elephant is almost impossible that you'll have an elephant on your production line, where tips of gloves are very likely to occur. So, it's not only what do you need to detect, but how often is that likely to happen? And the statistics on detection of that object will be very important. So do you actually have to detect every single elephant that ever comes on your line? Probably not. But if you have to, how do you actually test the detection system? Thank you. And so I talk a lot about questions and don't provide any answers. Really, the solution to a lot of these problems is looking at detection curves. And detection curves don't tell you just the smallest object or the largest object you can find, but also the probability with which you are able to find a given object. So you can see three detection curves there on this slide. And would you accept any of these for microscopic objects? Yeah, the detector 3 can see microscopic objects, but only close to 2-3% of the time. Is that really a true detector for those objects? Now, if you look on the right side hand, all three detectors are pretty good at detecting very large objects. So which detector would you choose? I would go, for example, in this case, with detector 3. It sees high percentage of smallish objects and sees 100% of all large objects. And again, performance is really determined by many aspects of the detector. It's not just the size of the object you're looking for. And the final aspect that a lot of people don't pay attention to is false positives. False positives is essentially when you're rejecting good product because you think it has something troublesome with it. And a lot of the times, many people will say, well, my false positive rate for my detector are 5% of the pixels or 0.5% of all the pixels. But each pixel, actually, if you have one pixel saying that it's a positive, you will reject a much larger amount of product. So what is the actual amount of product, or what's the time frame that you're rejecting when you find a positive? And again, that's a number that only you in your particular situation will be able to dictate. What amount of false positives can you afford to have in your production line? Thank you. So there are many different approaches to finding foreign object on lines. And one of the traditional methods that we all run to is, if a problem starts appearing, we put more inspectors online and more human inspectors online. And human inspectors, they will detect the craziest, tiniest objects possible. The problem is humans are really non-reliable detectors. Over time, their performance decreases. They just don't pay attention. And their performance is influenced not only by their eyesight and their vigilance, but also by conditions and how well they were trained and who's around them and all those other random things that just aren't true with machines. So the next modality we often use are X-rays. Next, please. And, X-rays have been used in food processing forever, and they're really great. They're amazing at finding embedded objects in calcified bones, in metal detection, in hard plastics, and so forth. The problem is our plants have been changing. So X-rays that can detect metals very often are terrible at finding things like soft plastics and low density plastics. So anything that floats in water, I think we all heard that, is not really detectable by X-rays. So we turn to metal detectors. And now they can find even smaller objects in more complex products and boxed products. The problem is metal detectors can only find ferrous or iron containing metals. And then as our products improve, gain complexity, so we add spices, we add salt, sensitivity changes. And that's actually something that's inherent for any detection system. You know that picture I showed you of finding a rock on a carpet? The more material you add into your production line, the more difficult any detection task becomes. Next, please. So what are the new approaches? Well, humans are pretty good at seeing tiny things. So why don't we emulate a human? Why don't we start using camera systems? Now, camera systems, the drawback here is they only see surface contamination. But there many other industries have been using cameras for decades now. So, you know, it's lower cost. It's easy to implement. There are many choices on the market. Can we use cameras? The problems that I talked about, those still start haunting you. Can you see a light colored object on a light colored background of processed meat? You know, the resolution, the noise levels, all of that impact cameras. So how people have approached this? Next, we started using cameras that see more than 3 colors. So just like your eyes that we see 3 colors, cameras see 3 or 4 colors. So people started using multispectral systems where now they're starting to pick specific wavelengths that provide information about specific materials. So maybe 10 color bands or maybe 20 color bands. Again, this has the similar limitations as just looking at things, but we're now starting to differentiate low contrast objects. And maybe we can target very specific chemistry of objects. So if you go to the proposed solution that PPO uses, hyperspectral imaging, next, we now look at hundreds or thousands of spectral bands, and I'll explain that in a little bit more detail. But you can now start looking at chemical differentiation of objects, and maybe objects you have never seen before are now detectable. The problem is with hyperspectral imaging, now for every pixel of your conveyor belt, you're collecting so much information that now you have to start worrying about how good are your algorithms and the software that runs your machine. Can we process all of that information quickly? And that's really one of the reasons why hyperspectral imaging has not been really adopted widely in many industries. It's only now that we have power, computing power fast enough that allows us to analyze all this plethora of information that you know, when you're generating 20 terabytes in a couple of hours, how on earth do you process that? So these novel technologies and new algorithms are really starting to enable us to look at more information, distinguish small bits of information in very complex systems. Next slide, please. So let's talk a little bit about vision and hyperspectral. After all, this is the PPO webinar, so we will talk a little bit about our objects here. But you know, you typically need some sort of source of energy or light that interacts with an object. You then detect the light that's reflected or scattered off of an object, and you display it or do some sort of manipulation of the data. Next. But light interacts with objects in very, very different ways. Some of the light is absorbed based on the chemical composition. Some light is scattered based on physical makeup of a surface, for example. So, you know, flat, icy surface will scatter light very differently than, you know, very structured and textured icy surface. And many of these are actually wavelength dependent. So you can tell a lot about a product based on how different wavelengths of light interact with it. And not only do you see chemical composition, but you can tell a lot about the structure of a product also by using wavelength-dependent detection. Next, please. So instead of looking at just camera image, what if we look at every single wavelength that of light that's impacting an object, and we then detect it and analyze it? Well, we can now identify chemistry and kind of physical appearance of the object in much more detail than if we just used cameras. Next. So to give you an example here, kind of putting everything together, this bacon actually has 8 foreign objects located on it. And none of the other modalities were able to detect those 8 objects. X-rays couldn't because some of them are cardboard. Metal detectors couldn't detect anything because nothing here contains any ferrous iron. Multispectral was not tuned to those wavelengths. Human inspectors couldn't see cardboard on the background, but the smart imaging or hyperspectral imaging not only seeing those foreign objects because they look different in the background, it was also able to identify them. And that's why we propose that using hyperspectral imaging really complements any other detection modality you might have installed on your system. Next, please. So looking at this in a slightly different way, let's imagine that the camera-based image is a picture, but you're actually seeing reality in the original image. So cameras and human eyes are almost identical. We see 3 colors here. And that's how we differentiate objects. On multispectral, we see, 10, 20 colors, and we can now start appreciating differences between different types of foreign objects, somewhat based on chemistry. But what if we tuned the multispectral imager to wavelengths that are actually not really important in differentiating? We might lose some of the information, and we might never be able to identify a foreign object that kind of falls between those wavelengths. So next. And then when you use hyperspec, you'd never lose any information. You actually have so much information that till recently, it was impossible to process it quickly. So this now allows us to really closely differentiate everything you see on the image. And you can start classifying each pixel by its composition, by its chemistry, and by its difference to the standard product you're expecting. Next, please. So the final aspect is, I talked a lot about detectors and detection and seeing and foreign and backgrounds and whatnot. But I think now is also the time to start paying attention to the software that's running your detection systems. We're now collecting so much information and so much interesting data that we have to interpret that. And being able to not only make a decision, is this detection or not, but also being able to store some of that information and look at time frames and start seeing trends in your data is now completely possible and very doable with systems like the PPO smart imaging. So we're now enabling not only the reject a foreign object, but start looking at the whole holistic approach and start looking at the entire processing line performance over time, and then interact with that line and maybe optimize things because you have so much information. Next. So things like trends, and next. And things like learning is possible, right? Like as you collect this data and you see trends over time, you can start learning information. So over time, initial foreign object detection might be a little bit messy, but as you see more and more of these types of foreign objects and you start seeing trends, what your background looks like, you're now starting to able to learn how to better detect. And again, complexity is difficult to deal with initially, but once you have it, tamed with good algorithms and good approaches, you can really take advantage of that complexity of information that you're collecting from all these detection systems and start implementing new and better routines as you go forward in time. Next, please. So I talked a lot about detection, but what is the gist of it? Well, when you're looking at a detection system, make sure that you really understand what is your problem that you're trying to address. It's not just the size of objects you want to find, but what are the materials that typically occur? What is the need for the size detection? Um, can I put a couple of different detectors that, one is good at this and the other one is good at something else? How many people should I have on the line? And then how much am I rejecting? If I have one of those perfect Olga detectors that rejects everything, yeah, I'll find all my foreign objects, but is that really what I'm looking for? So how much good product am I throwing out? And are there other additional benefits of combining several modalities? What other information will I be seeing? All of that is something to really look at when you're trying to solve a problem. These machines come with a lot of responsibility. They're not, zero cost. So why would you implement a given machine if you don't really understand the problem that you're trying to address? And I think this is a good segue to Casey's discussion now, because she will actually talk a little bit more about the problems that processors are seeing and kind of what are the trends that are emerging as processing is becoming more and more automated, faster, and the value chain is so complex right now. So thank you, and Casey, off to you.
Thank you, Olga. As usual, I learned a lot, and I've already been working on these things for a while now. So just a little background on myself. Heather mentioned I have some experience in the food industry, and I actually started out in chocolate and ingredients, and I've always been in food safety, quality assurance, or regulatory roles, and then I went into steak cutting mainly, but it was raw beef processing, a little bit of poultry, a little bit of pork. And then I found my true calling in pork slaughter, which I thoroughly enjoyed. And that's where I was recently for 4 years before joining the Meat Institute about 3 years ago. And what I noticed through my path through the food industry as it relates to detection is that I went from some of the easiest products to detect in. They were very uniform. They had small particle sizes. Finding foreign material in those types of products was you could be fairly successful, even with the technology that we had 10 years ago. And then as I went through the food industry, I kept going to places where detection was harder and harder and harder and more difficult, and the success rate was lower, albeit technology had even gotten better. Next slide. So yeah, what I found throughout my journey too was that there was a general lack of understanding. All the things that Olga went over, people in the plants didn't know when I was there. The vast majority of folks, we didn't understand necessarily how our systems worked. We didn't know what they would detect versus what they wouldn't detect. The number of people in a plant who think that a metal detector or an X-ray will solve all of your foreign material problems was staggeringly high, and it was the whole gambit. We had FSQA folks who are supposed to respond to incidents, not fully understand the capabilities of the systems they were working with. We had sales folks, guaranteeing things to customers that our systems couldn't deliver on, and then we have regulators still to this day. All of these folks, but regulators especially, we struggle with them not understanding the use of the equipment that we're using and its capabilities. Next slide, please. So both my parents are teachers, so my solution is almost always education, and I think it was very true here. So I started educating myself as I went through each of the different facilities that I worked with, trying to understand the capabilities of equipment. I read things, I asked questions, and had I had Olga's phone number back then, I think things would have been a lot simpler. But as I went through my path and started learning more, I realized that we have these amazing technologies, but we're not necessarily utilizing them in the right ways all the time. And it shows. We have a staggering number of FSIS recalls through the years. So we're talking US only right now, but it's a problem. It's a problem in Canada. It's a problem globally. But we'll use the US as an example. So in 2019, we had a record high number of recalls, 34 recalls for foreign material in product. That was 27% of all recalls that year. That was kind of that was our peak, but not in a good way. And people are noticing. I think there's a lot of reasons that it got that high in 2019, and we'll talk about a couple of those. First, we'll talk about the regulatory aspect of that, because obviously FSIS recalls have that regulatory component to them. In 2008, the Farm Bill required the USDA to implement regulations similar to FDA's reportable food registry, so that establishments would have to report when there was dangerous product that had entered commerce. So in 2012, FSIS followed through on the Farm Bill. We advised them to maybe do this regulation a little differently. The FDA reportable food registry focuses on class 1 or high risk products. 418.2 requires establishments to report all adulterated or misbranded products to the agency with no regard on risk level. And it also defines in commerce as any time it's left the establishment. So you have products getting reported that are going just to another processing establishment where whatever the issue is would be controlled. And then over the years, there's been increased focus from our regulators on these types of products. I think that is part of the equation on why we saw foreign material recalls increase. But that's not all of the equation. Next slide. As Olga mentioned, our plants look a lot different than they used to. There's a lot more automation, there is a lot more conveyors and equipment, and we are still a very people-heavy industry because of the unique element that is a live animal. But we are more manufacturing and automated than we used to. We get a lot of questions following 2019's peak in foreign material recalls from media about, is there more foreign material in the product, or why is there more foreign material in the product? And one of the things that gets pointed to often is automation. The industry is more automated, so obviously that's why there's foreign material. I'm not ruling that out as part of the equation. I think it could be part of the equation, but I think we need to remember that as we've been increasing our technology on the manufacturing side, we've also been increasing our technology on the detection side. So I think it's possible there's more foreign material in our product today than there was yesterday, but I think we also are finding more foreign material in our product than we did yesterday. I don't think we'll ever truly know what the balance of that equation really looks like. Next slide. And then the other thing that's changed is our consumers. So the consumer today is not the same consumer they were 20 years ago. Honestly, if I find foreign material in something that I'm eating and it doesn't cause me any harm, I'm probably just going to pick it out and throw it away. But not all consumers are like that anymore. Consumers report things more often than they used to, and they report in very different ways. Recalls are more easily conveyed out to the public and can get viral very quickly. We communicate with our consumers very differently. So the consumer is more aware and more interested in their food than they have been in the past. And they really care about their pets. So, we're looking at foreign material in pet food, where I think years ago that would not have been something that the industry would have necessarily been predicting. So at some point, we all had to come together and think about, okay, do we have more foreign material than we did yesterday? I don't know. Does it matter? I think at some point the industry, looked internally and said, regardless of whether we have more than we did yesterday, we have too much. So next slide. So we got together as an industry, and we decided to move forward with an effort to reduce the amount of foreign material that we have. It's that simple. We can argue about whether or not certain foreign materials should be reported, and whether consumers should be concerned, because most foreign material doesn't cause illness or harm. But at the end of the day, we could do better on the amount of foreign material in our products. Next slide. So when we talked about this, it kind of broke down into two different realms. Number one, it'd be nice if we could break less things. Then there would just be less foreign material. Over the years, we've done a lot really working on equipment and improving equipment, but there hasn't necessarily been a focus there on how to keep equipment from breaking to cause foreign material. And then we need to manage the things. So whether it's a thing that's broken and we need to figure out how to manage that better using detection and other methods, or managing our own processes, again, to prevent things from getting broken. So from this, next slide, came two projects. The first is the expansion of our sanitary design principles to become food safety equipment design principles. And for those of you that might be familiar with our sanitary equipment design principles, they came out of the era of the industry really taking hold and trying to reduce listeria contamination. So they're very focused on the microbiological hazards that may or may not come with equipment design. So in looking at foreign material, there are many things that we can do with equipment to help prevent the equipment from being that foreign material hazard. So as we were opening up these design principles to expand and think about foreign material, we wanted it really to cover all of food safety. Typically speaking, that means microbiological hazards and foreign material when you're talking about equipment, but we wanted to make sure it was as encompassing as possible. This working group has been doing some amazing work over the last year. There's some really good insights and examples that we're including in this document. I'm very excited about it. But the bigger project, next slide, has been what I lovingly refer to as the Foreign Material Manual, as a very long working title. But this really, a lot of the stuff that Olga went over, kind of, explaining the different types of detection systems, what they're capable of, what they're not capable of, that whole concept of a multi-hurdle approach, that's all in this manual. This is not a best practice document. It is a huge document encompassing everything we could possibly think of for an establishment to consider when designing their own program. Because as Olga mentioned, each establishment is going to be a little bit different, and you're going to have to cater your program into what works with your process. We suggest a multi-hurdle approach, but that may not make sense for all systems. We understand, there are some simpler systems where maybe there is, one thing that you're targeting and a multi-hurdle approach doesn't make sense. But generally speaking, you're probably looking at something like a multi-hurdle approach. And this is going to walk you through all the different prevention programs like GMPs or preventative maintenance programs, all the different detection methods with good examples, maybe some of the same pictures that Olga had showed you, and then a whole series on how to respond to an incident once you've had one, and best practices and things to think of. We point to best practice documents that exist, but again, that's not the intention of this manual. If you tried to use this as a best practices document and use everything in the manual, you would do nothing else but focus on foreign material. It's really set up to educate and inform the industry so that you can use tidbits throughout the manual to design the best program for you. Both of these projects are really getting close to completion. We're very, very excited about both of them. We predict and intend to publish both of these this summer. Along with those, we will be coming out with webinars, hopefully in the future, some kind of workshop similar to our Listeria workshop that's focused entirely on foreign material control. Because at the end of the day, we do need to do better as an industry. I will say even since 2019, I think we are doing better. I think folks have really tuned in. I think there's been a lot of good conversation coming out from these projects and from other initiatives. So I'm excited to see where our industry goes. We, in the past, have a great history of identifying an industry-wide problem and coming up with industry-wide solutions. So thank you very much for having me today, and I look forward to any questions.
Awesome. Thank you so much, Casey. That was amazing. I'm trying to get my camera working here again. So I hope everybody got an opportunity to think of some questions from the slides today and from Olga's and Casey's presentations. But maybe what I'll do is I'll actually selfishly kick it off and ask the first question while we give everyone else an opportunity to bring things, to gather their thoughts and type some questions into the Q&A. And please don't forget, the Q&A button is down at the bottom of your screen in the little black bar. There I am. So you can throw a Q&A or question into the Q&A anytime. So Casey, I'm going to put you on the spot first, but I will ask Olga the same question. And it's, do you see any trends in the industry around detection right now? So for example, are we seeing increased use of different detection modalities? And if we're not seeing those trends, should we be?
Yes, I definitely see trends. I think one of them is, I think establishments are doing a better job of looking at the multi-hurdle approach. Again, historically speaking, if you walked into establishment, primarily what you'd find is a metal detector. And they're very useful in a lot of the things that we're looking for in an establishment, but they're not a one-fits-all solution. So I think we've got establishments that are understanding, you know, maybe I need a metal detector and a X-ray. We have seen an uptick in people that are interested in vision systems. Again, I think those are still new to the industry, but it's a new fun toy that we definitely want to play with. And we've been using vision systems for some other things anyway. So using them for foreign material detection seems to be something our members are increasingly more interested in. But yeah, that concept of using more than one is definitely gaining traction in the industry.
Awesome. Well, guys, so you're on mute. Do you want to jump in and add your thoughts as well?
I would agree with Casey. What we have been seeing a lot of, though, in addition to this, is significant labor shortages across North America, and that certainly seems to be increasing, especially in the COVID and post-COVID world. So automation is definitely much more top of mind with anybody that we're speaking with than it was even 2 years ago. And I think those trends will continue.
Awesome. So we do have a question from our audience, and I'm just going to read it out, and then I think both of you can probably offer your comments on it. What value beyond differentiation analysis, or FMD, does the data have for food safety, i.e. for other analytical properties that are of concern for mass detection and identification?
Looks like a question for me, so maybe I'll attempt to answer this. So a very good question, and I think it really depends on the type of detection system that you're using. But I think trend analysis, regardless of what's the technology underlying it, is super important. So like if you're starting to see all of a sudden huge increase in detection of X, that might trigger an inspection of your entire value chain and your entire process. If you look specifically into hyperspectral and smart imaging, we certainly can provide information about other compositions, like water holding capacity of meat, for example, which might lead to better or more aggressive growth of pathogens or something like that. So as we're monitoring more and we're starting to see we can connect more events together over time as well, I think, where that's really what I'm looking forward to in the industry, where we get deeper and deeper understanding of what impacts what. Like, how does stress of your slaughter affect the quality of meat coming out, or do you get, for example, slightly different yields and pathogen growth patterns in stressed animals? I think those are kind of the questions that we will be able to answer soon as we get more and more interesting and complex detection modalities.
One thing I'll add that I learned from Olga through this experience working on these foreign material efforts is that these imaging systems can do a much better job than anything else we really have as a tool on organic matter. So things like fecal and just that we don't really have a detection system for other than physical human being inspectors. So I'm excited to see maybe some folks look into that as a potential use.
Awesome. So there's now a follow-on question to the last question. How does AI participate in this conversation?
Doug, I love your questions as always. I think, again, the ability to learn from past experiences and to connect things that to us humans look random and disjointed. I think those are the kind of two huge advantages of AI. Like consider what we've done in just, image search on the internet, right? Like it was only in 2012 when algorithms became better than human beings from recognizing faces. So what will this look like? I bet you it's possible now to predict a lot of diseases from just looking at human faces on internet search. Hopefully it's not implemented because there's a whole bunch of privacy laws, but I think that's the nice thing about the food industry is as we're have these systems collecting more information, we can start also looking at trends across the globe, really. We can start seeing these geographical trends and trends from plant to plant, which I think will teach us a lot about how to optimize our production. And I hope make it safer, make it healthier, and make it less wasteful. And those are, let's face it, at the end of the day, anything that reduces wastes and makes things safer and healthier improves our margins as well.
Yeah, Olga makes very good points. And I think that's something industry has been really, like our next step that we've already been focused on for a while has been, we've taken data points over the years. We've taken lots and lots of data points over the years, but primarily they have sat there. We took them because we needed to take them or felt that we needed to take them. After the day that we took them, we didn't look at them and we didn't really do anything much with it. But today, you're seeing companies really using their data. And I think over the years, there's been more and more folks realizing, okay, well, I also have this data and this data. And now that we've really understood that we can learn from our data and really analyze it, I think AI is easily the next step. There's already companies that are utilizing it and looking into it. So I think we've maybe behind some industries on data analysis, but I think we're ahead of many others on using the data that we've been collecting.
I'm going to ask one more question. We've talked a little bit, and Casey, you just referenced, other industries that we might look at and learn from. What technologies are in use in other industries that you could see potentially having relevance and that we might want to be keeping our eyes on for the future in food processing? And you can both answer that question because I know Olga has an opinion too.
Well, I'll let Olga finish up because she'll do a better job than I will. I will say, I think part of it is even just the technology that we use in our own industry. I think we sometimes underutilize. So I think we have technology that we've put in place, and I think it was Doug's question. It is a great example of this. FSQA may want a technology for a specific reason, but they don't realize, or we don't think about the fact that that same technology could have benefits to the operations side or the margin side. So I think we've definitely been opening those doors and realizing that by having better conversations throughout the different departments and really understanding what all of our different technology is capable of, we can get more information out of what we have. We may put a piece of automated equipment in, to reduce the number of staff that we need, but then we realize it's also taking all this data that could tell us quality things. So I think number one, we need to do a better job, I think, and we're getting there on looking at the information and the technology we already use. I think we're fairly advanced as far as the food industry goes, but obviously there's always things that we can learn from different folks just within our own food industry.
Yeah, and if I look, I always look at medicine. What does medicine allow us to do right now? And if short of a tricorder, if you're a Trekkie and a geek, Something like MRI imaging for all meat, for example, would be fantastic, right? Like it does some spectral analysis. It does soft tissue differentiation, so it's not dependent on density, and it can look through volumes. Now, I think the task of implementing something like that at a decent cost and without disrupting our existing lines, that's where the difficulty lies. But just, another decade or two, and we'll have that, right? Like it will be just more information about something else. And I agree with Casey. Like sometimes it's not that you have the wrong equipment, it's just that you're not using it to its full potential. So I would argue that more important, to Casey's point, is education right now than trying to invent yet another technology to solve problems.
Awesome. So we have one more question that's come through, and I think, Olga, this one's for you. Can hyperspectral imaging find embedded foreign materials or just on the surface? Is a mono or single layer required?
Yeah, it really depends. Meat does allow some transmission of light, especially in the near infrared range. So very large embedded objects that are very different from the product, technically yes. But if I had to answer quickly in 2 words or 1 word, no. It's really what your eyes can see. That would be the rule of thumb for hyperspectral imaging at this stage. And again, we're seeing slightly different wavelength ranges and whatnot, so light penetrates, but I would say it's several millimeters under the surface maximum penetration.
Awesome. All right. Well, I'm looking at our time and we're rolling very quickly up to the hour. So I think with that, we'll end the webinar for today. If you do have questions, please feel free to reach out to sales@ppo.ca. And as I said before, we'll post the recording of our webinar on our website within the next 24 or 48 hours. So please feel free to find it at ppo.ca/resources. I'd like to thank Casey very, very much for making time for us today and being part of the webinar. It's really appreciated. And we have had a little tiny contribution to the 2 documents Casey referenced, and we're really looking forward to seeing those come out over the next few months. So that's pretty amazing, and hopefully should help advance the industry when it comes to detection of foreign materials. Thank you, Olga, as well, for being part of this. And thank each of you for making the time for us today. There'll be another webinar coming out soon, so do keep an eye on your email, and we'll make sure we let you know when that's going to happen. So enjoy the rest of your day, and thanks again. Take care.
Thank you all. Thank you,
Thanks,
Casey. Bye-bye.
Bye for now.